Welcome to the Explainer. If you're a focused learner looking to figure out how modern data architecture can actually keep up with the intense, nonstop demands of artificial intelligence, well, you are exactly where you need to be. Today, we're tackling a topic that's absolutely crucial right now: database availability in the era of AI. And we're looking at it specifically through the lens of pluggable standby databases in Oracle 26a. Our source material kicks things off with a pretty bold but true statement. Data is valued like gold in this day and age. Engineers everywhere are being pushed to pour massive amounts of time and resources into AI projects. But there's a huge hidden trap here. Businesses are racing to get the most value out of fast-developing AI technologies and frameworks like MCP. But here's the thing. An AI framework is literally useless without access to data. If that data isn't consistently available and tightly protected, your AI simply isn't going to reach its full potential. Which brings us right to the stakes of the whole thing. What happens to your AI projects when the database actually goes offline? Because let's be real, even as we all migrate to the cloud, unexpected outages still happen, for sure. And on top of that, organizations regularly have to perform planned downtime activities, like disaster recovery or DR drills. You simply can't pause your critical AI systems every single time a database needs maintenance. It doesn't work that way. Okay, let's dive into this. Here is our roadmap. First, the AI data challenge, then the Oracle 26 AI solution, followed by architecture and prerequisites. Then we'll get into the actual setup with database and wallet prep, data guard broker setup, and finally instantiation and validation.
Section 1, the AI data challenge, the need for uninterrupted data.
So while organizations are rushing headfirst to optimize their AI models and spin up new architectures, they kind of completely overlook the foundational layer, database availability. To really understand the fix here, we have to look back at the evolution of Oracle Data Guard. In older setups, legacy Data Guard was managed strictly at the container database, or CDB level. This was basically an all-or-nothing approach for switchover and failover. If you consolidated multiple pluggable databases, PDBs, into one single container for efficiency, you still had to fail over the entire container, even if just one PDB had a glitch. It was like shutting down a whole apartment building because one unit had a leaky faucet. But now, fast forward to Oracle 26i Data Guard. We finally have PDB-level granularity. You can run read-write PDBs right alongside standby PDBs in the exact same container. As our source material explicitly calls out, this flexibility is a true game changer.
Section 2, the Oracle 26 AI solution, granular DR and optimized licensing.
This is exactly where organizations can finally balance their aggressive AI innovation with highly available, super reliable systems. The formal definition of a pluggable standby database really highlights why it's so interesting. It's a configuration that allows independent management of pluggable databases for switchover and failover. It offers granular disaster recovery without affecting the rest of the container database. So, what does this actually mean for you? It means you massively lessen the business impact during a failure, because all your unaffected pluggable databases just keep running normally. And crucially, by letting you pack workloads tightly together while preserving high availability, it heavily optimizes those expensive Oracle database licenses. Win-win. Section 3, Architecture and Prerequisites, Building the Blueprint. We're moving from the why to the what. Let's map this out clearly so we have our environment straight. Our source database is named ORLCDB. Think of this as the primary container for the pluggable database we want to protect, which we're calling ORLCDB1. Then we have our target database, named ORLCDBS. This is going to act as the standby environment. It will host the standby PDB, named ORLPDB_DG. But remember, and this is the cool part of the 26a features, this target container can simultaneously host its own completely separate active read-write PDBs. Our ultimate goal here is pure replication, protecting the primary PDB while the target container remains totally active for other workloads. Now, to make all this magic happen, there are a few strict prerequisites. Obviously, you have to ensure network connectivity between the source and target hosts, so maybe VCN peering if you're working in the cloud. You'll also need 2 Oracle read-write database environments running Oracle Database 26 AI to unlock that full data guard PDB support. But I want you to focus on this last point. It's a surprising fact, but a separate standby CDB is not required to configure data guard for a pluggable database anymore. Section 4, Database and Wallet Prep, Setting the Foundation. Let's move to and see how this builds. Okay, both the source and the target container databases must be prepped for data guard. And a huge part of this, which actually started back in 21C and continues into 26AI, is that you absolutely must use the exact same SIAS password for wallet-based authentication. We can boil the command line requirements down into 4 conceptual steps. First up, create a wallet using the mkstore command. Second, add your SIAS credentials right into that wallet. Honestly, if you don't use a wallet to hold these credentials, some of the data guard configurations are just going to flat out fail. Third, you've got to add the wallet location into the sqlnet.aura file on both nodes. And fourth, restart the listener on both nodes so all those changes actually take effect. Section 5. Data Guard Broker Setup. Linking the environments. For this part, you're going to use the Data Guard Broker command line interface. Step 1. You create the primary configuration on your source database. Step 2. Add the standby configuration for the target. Step 3. Issue the command to enable configurations on both of those nodes. Step 4 is where it gets specific to pluggable databases. You run the prepare dg-pdb command. Just keep in mind, executing this command assumes that both of your container databases are already fully configured and enabled. This step is what unlocks and resets the password for the dg-pdb_int account on both containers.
So the absolutely crucial point here is this specific command, add pluggable database. Running this on your source database is what officially adds the standby PDB, roclpdb_dg, to the target container, mapping it directly back to your source pluggable database. That's the link.
Section 6. Instantiation and validation, moving data and testing. So right now, your standby PDB technically has no data files, which means we need to manually copy them over before we can test anything. While tools like RMAN are usually preferred for their robustness, our source outlines a chronological manual workflow using SCP, or secure copy. It's kind of like manually packing up physical filing cabinets from one office, driving them across town, and setting up shop in the new building. Here's the timeline. First, on your source pluggable database, you execute alter database begin backup. Second, transfer the actual data files over to the target directory via SCP. Third, go back to the source and execute alter database end backup. And finally, step 4, you use the rename files SQL command on the target so the control file knows exactly where to find those newly copied physical data files. Now, right alongside the data files, you also have to manage your logs. You must create standby redo log groups, or SRLs, on the target pluggable database. And there's a strict rule here. The size of these standby redo logs must exactly match the size of your online redo logs. No exceptions. This is an absolutely essential step because it's the very thing that supports the real-time redo apply process, which keeps the standby perfectly synchronized. Okay, once everything is copied over and the standby redo logs are properly sized and set up, you just need to flip the switch. Using the Data Guard Broker, you issue this simple command to set the state to apply on. Just like that, the real-time apply process begins. And this brilliantly illustrates how you can actually validate that the whole thing is working. By querying the Managed Recovery Process, or MRP, on the standby database, you are looking for a clean validation output. You'll see various processes running, like Arch, MRP0, and RFES, along with their status and sequence numbers. When you spot that MRP0 process sitting comfortably in a wait-4 log status, bingo, you've just validated that redo apply is functioning correctly, and your granular DR setup is officially active. Which brings us to our final and maybe most important question for you to chew on. Is your AI infrastructure built on an unbreakable data foundation? As we all deploy these complex, incredibly data-hungry models, the underlying availability of your database simply cannot be an afterthought. Oracle 26AI's pluggable standby databases give you that precise, granular control you need to ensure your AI projects never go dark during a localized failure. So take some time to review your DR strategies, ensure your data is highly available, and make sure your foundation is truly unbreakable. Thank you so much for joining me on this explainer. Keep learning and keep building.